Here we will see microservice in microservice architecture. In a microservice architecture, instead of building a single massive codebase, developers break the application down into a collection of these independent loosely coupled services which are known as microservices. A microservice is a small, autonomous and self-contained software application that executes one specific business capability. Each microservice runs its own unique process and usually communicates with others through lightweight protocols like HTTP, REST API or asynchronous message brokers. The core design principles of robust microservice are business domain alignment. Here services are modeled around specific business capabilities. That is, they are separated by modules such as inventory, payment, etc. rather than UI and database. Then decentralized data management. Each microservice has its own database which ensures strict decoupling and autonomy. No single database should be shared across multiple services. Then independent deployability. Microservice must be updatable, deployable and scalable without requiring changes or redeployments to other parts of the application. Then loose coupling. Dependencies between different microservices must be minimized. Microservices communicate only through well-defined network-based APIs, which allows teams to use verifying technology stacks if needed. Then failure isolation. The system must be designed with protection. That is, if one microservice fails or slows down, the entire application shouldn't crash. And high observability. Because the architecture distributes functionality across multiple services, comprehensive monitoring, distributed tracing, and centralized logging are essential for diagnosing latency and system failures. Each individual microservice is built like a complete miniature application. It typically includes the following elements to make it truly autonomous. First, single responsibility. It focuses strictly on one bounded context such as managing user profiles, processing payments or generating recommendations. Then dedicated code base. It is developed, versioned and maintained in its own repository which allows a small focused team to own it entirely. Then independent database. It uses database service pattern. No other microservice can directly access or modify its database tables, which protects data encapsulation. Then polyglot design. Since it is isolated, it can be written in whatever programming language or framework that fits its specific task based. And independent deployment. It can be compiled, tested and pushed to production using its own CI/CD pipeline without needing to deploy or restart the REST application. A single microservice cannot work alone. A complete microservice architecture requires supporting structural components to manage traffic, discovery and health. These components are first API gateway. It acts as a front door. It receives client requests, handles security checks like authentication and routes the traffic to the appropriate backend microservice. A dynamic directory where running microservices log their current network locations so they can discover and talk to each other. Then message broker. Platforms like Apache Kafka or RabbitMQ manage asynchronous event-driven data streaming between services, which ensures they start synchronized without blocking each other. Systems like Kubernetes that automate the container deployment, auto-scaling, and health monitoring of hundreds of different microservice instances. And observability framework. Centralized logging and distributing tracing tools track client requests across multiple service boundaries to quickly find latency bottlenecks or errors. Microservices require structured protocols to talk to one another securely and efficiently. These generally balance synchronous and asynchronous paths. Synchronous path is used when a real-time response is required. It is implemented via standard HTTP client calls or high-performance gRPC protocols. And asynchronous is used to decouple services during transitional updates. One service publishes an event and interested services consume it. This is often automated using packages like mass transit over message brokers like RabbitMQ or Azure Service Bus. Instead of giant tightly coupled system, microservices offer several advantages. First, independent scaling. You can scale individual service with high demand rather than entire application. Then technological freedom. Teams can use different programming languages, frameworks and databases for different services. And faster updates. Services can be developed, tested and deployed independently, which speeds up the time to market. And if one microservice fails, it does not necessarily crash the entire application. An example of microservice is an independent payment service in e-commerce app. It only handles secure transaction processing and payment data. Since it is separated from the rest of the application, developers can update it to support new payment methods without affecting the core shopping cart or catalog.